Greetings, explorers of the unknown, and welcome back to the Hidden Hour, your go-to channel for unraveling the strangest mysteries of the universe. Today, we're diving deep into one of the most intriguing enigmas ever recorded in the search for life beyond Earth, the WOW signal. Picture this. It's a quiet night in 1977, and a scientist in Ohio picks up a radio burst so astonishing that he scribbles, "Wow," on a piece of paper. That single word sparked a quest that's lasted nearly 5 decades. Was it a hello from an alien civilization? A cosmic fluke? Or something closer to home? Here at the Hidden Hour, we love peeling back the layers of the unexplained. And this story has it all: science, wonder, and a puzzle that refuses to be solved. So grab your headphones, settle in, and let's journey into the starry abyss to explore the mystery of the WOW signal. The night it all began. The story starts on August 15, 1977, at Ohio State University's Big Ear radio telescope. This wasn't your typical stargazing setup. The Big Ear was a massive, football field-sized structure, built to capture radio waves instead of visible light. Imagine it as a giant ear, tuned to the whispers of the cosmos. That night, astronomer Jerry Ehman was on duty, sifting through data from the telescope's latest scan. The Big Ear didn't record sound clips or images. It spat out numbers and letters on a continuous paper printout, each character showing the strength of radio signals from space. Most of the time, it was a monotonous stream of low values, just the hum of cosmic background noise. But at 10:16 p.m., something extraordinary broke the pattern. A sequence appeared: 6EQUJ5. To the untrained eye, it might look like gibberish, but to Ehman, it was a bombshell. It meant a signal 30 times stronger than the usual noise had hit the telescope, lasting exactly 72 seconds. Stunned, he grabbed a red pen, circled it, and wrote, "Wow," next to it. That spontaneous reaction gave the signal its name and cemented its place in history. What made this signal so special? First, it was detected at 1420 MHz, a frequency called the hydrogen line. Hydrogen, the universe's most abundant element, naturally emits radio waves at this exact spot, making it a logical choice for any civilization trying to say, "We're here." Scientists had long theorized that if aliens were broadcasting, they'd pick this frequency as a universal handshake. Second, the signal was narrowband, meaning it occupied a tiny, precise slice of the radio spectrum. Natural sources like stars or pulsars tend to blast out wide, messy signals, but this one was sharp, focused, almost deliberate. And then there was its duration, 72 seconds, matching the time it took the Big Ear's beam to sweep across a fixed point in the sky as Earth rotated. It appeared, peaked, and faded, just as a distant source would. Ehman knew he'd stumbled onto something big, but he couldn't have predicted how it would captivate the world. Decoding the signal's secrets, let's break down what that 6EQUJ5 code actually means. The Big Ear assigned numbers and letters to signal strength, with one being weak and higher values showing more power. After 9, it switched to letters: A for 10, B for 11, up to Z for 35. The sequence 6EQUJ5 translated to intensities of 6, 14, 26, 30, 19, and 5 over 6 12-second intervals. That peak at 30, the U, was the jaw-dropper, far above the usual ones and twos of background noise. This wasn't a faint whisper, it was a shout. The signal came from the direction of Sagittarius, a constellation rich with stars and cosmic wonders, adding to the intrigue. But here's the kicker: it never came back. The Big Ear kept listening to that patch of sky for weeks, months, even years. But the WOW signal was a one-hit wonder. That silence turned a fleeting detection into a full-blown mystery. Why didn't it repeat? If it was a beacon from an alien world, maybe it was a one-time transmission, like a cosmic flare shot into the void millions of years ago. Or perhaps it was intermittent, and we just missed the next pulse. The Big Ear's design didn't help. It had 2 feed horns, like dual antennas, scanning slightly different parts of the sky. A signal should have hit both horns a few minutes apart. But the wow signal only triggered one. That quirk fueled debates about its source. Was it too brief to catch twice? Or was it something else entirely? The data gave clues, but not enough to crack the case. What we do know is that the signal's traits, its frequency, strength, and narrowness, matched the profile of an artificial transmission. The kind SETI, the search for extraterrestrial intelligence, had been dreaming of since its inception. The alien hypothesis, the idea that the wow signal came from extraterrestrials, is the most thrilling theory. Imagine an advanced civilization, light years away, aiming a powerful transmitter at the stars. Maybe they were sending a greeting, a map, or just a signal to say, "You're not alone." The hydrogen line frequency supports this notion. It's a cosmic calling card, a spot any spacefaring species might choose. The signal's narrow focus suggests intent, not the random sprawl of natural emissions. Carl Sagan, the famous astronomer, once said the universe is so vast that it'd be surprising if we were the only ones here. The wow signal fits that vision perfectly. It's what SETI hoped to find, a clear, unmistakable sign of intelligence. But there's a flip side. If it was aliens, why only once? A civilization capable of such a broadcast might send it repeatedly, like a lighthouse sweeping the galaxy. Some speculate it was a moving source, like a spaceship or probe passing Earth's line of sight. Others think it was a one-off event, a burst of energy from a dying transmitter or a celebratory signal marking some alien milestone. The possibilities are endless, and that's what makes this theory so compelling. It's not just about science, it's about imagination. The wow signal lets us dream of distant worlds, of beings gazing at their own skies, wondering if someone's listening. Yet, without a repeat, it's a hypothesis that teeters on the edge of belief and skepticism. Natural explanations. Not everyone buys the alien story. Some scientists argue the wow signal has a more mundane origin, rooted in the natural universe. One leading theory points to comets. In 2017, astronomer Antonio Paris suggested that a comet, specifically 266P, Christensen or P. 2008 Y2, might have been the culprit. Comets release hydrogen gas as they heat up near the Sun, and that gas can emit radio waves at 1420 MHz. Paris calculated that these comets were near Sagittarius in 1977 and later observed them, detecting similar signals. It sounded promising, a natural source mimicking an artificial one. But critics poked holes in it. The Big Ear's dual horns should have picked up the signal twice if a comet was drifting through. Yet only one horn registered it. Plus, comets move slowly, while the signal's 72-second arc matched the telescope's fixed sweep. Not a wandering object. Paris stood by his work. But the debate rages on. Another natural contender is a cosmic phenomenon we haven't fully grasped. Pulsars, neutron stars that spin and beam radio waves, were considered, but they pulse regularly. Unlike the wow signal's single burst, a rare event, like a micrometeoroid hitting a gas cloud and sparking a brief emission, might fit, though no such process has been proven at that frequency. These ideas stretch our understanding of astrophysics, showing how much we still don't know. The natural explanation camp argues that Occam's razor, the principle favoring simpler solutions, leans away from aliens. Yet, the signal's precision keeps them scrambling for a perfect match. Could it be us? Then there's the terrestrial theory. The wow signal might have come from Earth. Radio telescopes are sensitive, and in 1977, the skies were already buzzing with human activity. Satellites, planes, even a microwave oven could have interfered. Maybe a secret military test bounced a signal off space junk, fooling the Big Ear. The frequency, 1420 MHz, is protected for astronomy, but rules get broken. A one-time glitch from a passing craft could explain the lack of repetition. However, this theory has gaps. Satellites use different bands, and no documented transmission matches the signal's profile. The strength and narrowness also defied typical interference. If it was human, it was an anomaly, a ghost in the machine we can't trace. To test this, researchers combed records of 1977 space traffic. Nothing lined up perfectly. The Big Ear team even checked their equipment, ruling out local noise like a car engine or a prankster with a radio. The signal's cosmic signature, tied to the hydrogen line, leans away from earthly origins. Still, the terrestrial idea lingers, a reminder that our own technology can muddy the search for the stars. It's a humbling thought. What if the greatest mystery of SETI was just us, shouting into the void? The search continues. After August 15, 1977, the hunt was on. The Big Ear team didn't shrug and move on. They scoured Sagittarius for encore. But the sky stayed silent. Other observatories pitched in, from Arecibo in Puerto Rico to the Very Large Array in New Mexico. Decades later, cutting-edge telescopes like the Green Bank Observatory joined the effort. Yet, the WOW signal remained a singleton. This persistence shows how seriously scientists took it. They weren't chasing a fluke, they were chasing history. The Big Ear itself met a sad end in 1997. Torn down for a golf course. But its legacy lives in the data it left behind. SETI took the signal as a gold standard. Projects like the Allen Telescope Array and Breakthrough Listen, backed by big names like Stephen Hawking, scanned billions of stars, tuning to 1420 MHz. They've caught oddities, signals that tease the imagination, but none with the wow signal's clarity or context. The original data is a treasure trove. Though limited, it pinpoints a region, not a star, and lacks the precision of modern tools. Researchers have modeled possible sources, from orbiting planets to drifting probes. But without a repeat, it's all guesswork. The silence is deafening, yet it drives innovation, pushing us to build better ears for the cosmos. A cultural phenomenon. The wow signal isn't just science, it's a cultural icon. It's popped up in sci-fi novels, documentaries, and even video games. X-Files fans might see it as Mulder's Holy Grail. It's a shorthand for the unknown, a real-life riddle that blurs fact and fiction. Jerry Ehman became an accidental celebrity, though he stayed cautious, never fully endorsing the alien angle. The signal's allure lies in its ambiguity. It's a blank canvas for our hopes and fears about the universe. Are we alone, or is someone out there, just out of reach? That tension keeps it alive in the public mind. A story that doesn't need an ending to resonate. It's also a testament to human curiosity. The wow signal isn't a dusty footnote, it's a spark. It's taught us to question, to listen, to dream. Schools teach it, podcasts dissect it, and here at the Hidden Hour, we're obsessed with it. It's a bridge between the cold logic of science and the warm glow of wonder. That balance is why, nearly 50 years later, we're still talking about 72 seconds of radio noise. Lessons from the void. What does the wow signal teach us? For one, it shows science isn't always tidy. Mysteries linger, and that's okay. It's a humbling nudge that the universe doesn't owe us answers. It also highlights our progress. The Big Ear was a clunky pioneer. Today's telescopes dwarf it in power and scope. Future projects, like the Square Kilometer Array, might catch what it missed. The signal's a benchmark, a challenge to keep pushing. Whether it's aliens, comets, or us, solving it would ripple through astronomy, technology, even philosophy. It's a reminder that the biggest discoveries often start with a wow. It's also personal. For Ehman, it was a career-defining moment. For SETI, it's a rallying cry. For you and me, it's a chance to ponder our place in the grand scheme. The signal's brevity, a fleeting blip, contrasts with its staying power. It's a whisper that roars, a puzzle that invites everyone to play detective. As of April 27, 2025, it's still unsolved, and that's part of its magic. The wow signal isn't just a signal, it's a story. One we're all writing together. Conclusion. And there you have it, folks. The sprawling saga of the wow signal. A cosmic cliffhanger that's kept us guessing since 1977. From a quiet night in Ohio to the edges of human imagination. It's a tale of science, speculation, and the search for something bigger. Was it aliens waving hello? A comet playing tricks? Or our own tech throwing a curveball? We may never know, but the journey's what counts. If you loved diving into this mystery with us here at the Hidden Hour, smash that like button, share this video with your fellow truth seekers, and hit subscribe for more adventures into the unknown. We're just getting started, so stick around. Until next time, keep your eyes on the stars and your mind open to the impossible. This is the Hidden Hour. Signing off. See you in the next mystery.